Hello, this is Mrs. Ross, and this is Lesson 18. We're going to talk about polygons, similar and congruent. And before we get off of this page, I'm going to define all of those terms for you because they're all math vocabulary. Okay? You can find this practice set on page 124 of your Saxon Course 2 textbook. So let me define some of these terms. So a polygon is going to, there we go. This is what you would consider a shape with straight lines. It's a closed shape with straight lines. Okay, so a circle is not considered a polygon, and then something that doesn't have a closure is not considered a polygon. Otherwise, it doesn't matter how many straight lines are connected. If it's closed, it's a polygon. Okay. And then the words similar and congruent in math terms. Similar means same angles, different side length. And you may want to put all of this in the back of your spiral so that you have these definitions, because you're going to see these again. And congruent is just a fancy word for same, like exact, same. Angles and sides. Okay, so let's go ahead and try and put these into practice. What is the shape of a stop sign? It is an octagon, an 8-sided figure. Let's see if I can draw one. Is it a hex? No, it goes down like that, and then it goes like that. Yep, then it's a stop. Okay. What do we call a regular quadrilateral? All right, so let's break these down. I'm going to get some different colors here. If a figure, this is a math word, or I mean, we're using it in that term here, but regular means all sides are same length. If you have a regular hexagon, all 6 sides are the same length. But quadrilateral, quad means 4. So what do we usually call a 4-sided figure where all of the sides are the same length? It's a square. Kind of like a math riddle. Okay. What kind of angle is each angle of a regular triangle? So a regular triangle is also called an equilateral triangle because all the sides are equal. So if I attempt to draw this triangle where all the sides are equal, you can see all of the angles are less than 90 degrees, right? And an angle that's less than 90 degrees is an acute angle. All right. Are all squares similar? How do you know? Now remember from the first page, similar means the angles are the same, but sides are different. Or the lengths, sorry. Different. So if I have this square, and then I have this square, my angles are the same, right? But this has shorter side lengths than this guy, right? So the answer is yes, because they all have the same angles. That's how you know. The same angle. And let's change colors here because I'm running. Are all squares congruent? Okay, so this is a different word. This means they're the same. And I've just drawn 2 that are not congruent. Congruent means exactly equal. So this is a no. And then it says, sketch a pentagon, 5 sides, a hexagon, 6 sides, and a heptagon, 7 sides. Oh, this should be interesting. So a pentagon kind of looks like this. It's like a baseball diamond. 1, 2, 3, 4, 5. We're good. Hexagon, oh boy. 1, 2. There we go. Kind of like a diamond. And I'm supposed to, okay, heptagon. 1, 2, 3, 4, 5, 6, 7. That's beautiful, Mrs. Ross. Well done. Okay. All right, referring to example 4, which angle in ABC corresponds to X, Y, Z? Well, hold on a minute, let me grab example 4. Okay, so what I've done is on the next page I've copied and pasted example 4 and example 3. We're going to need both of them for G and H. And these examples are in your book, so I just kind of used a snipping tool to get to it. But G says, referring to example 4, which angle in ABC corresponds to angle Y in XYZ? So let's go to the next page. So which angle in ABC corresponds to Y? Okay, so let's see. This looks like a 90-degree angle, and this looks like a 90-degree angle. So this probably, C probably corresponds, and this is a really weird, it's kind of a ish math term, to Z, which means A corresponds to X, and Y is going to correspond to B. So I think that that is our answer. Let's go back and make sure we're answering the right question. Yes, it's going to be angle B. All right, referring to example 3, are all angles in figure 2 larger in measure, smaller in measure, or equal in measure to the corresponding angles in figure 1? So basically, are the angles in figure 2, are they bigger, smaller, or equal than figure 1? Let's go check it out. Wrong way. Here we go. Oh, okay, I see now. So here's figure 1, and here's figure 2. They are similar. The angles are the same. The sides, hello, are different. Okay, can you see that? This is a smaller rectangle, this is a bigger rectangle. There's no, the angles are the same. So let's go back and answer that. So equal in measure. All right. I draw a triangle that contains a right angle. So here we go. Beautiful, beautiful. There's my right angle. Label the vertices A, B, and C. So the right angle is at vertex, fancy word for corner, C. So it really doesn't matter where A and B go. Beautiful. Which of these figures is not a polygon? Write your reason why. So remember, a polygon is a closed shape with straight lines. All right, closed shape, straight lines, this is a polygon. Closed shape, straight lines, that's a polygon. This one has this big open spot. Wah, wah, not a polygon because it's not closed. Okay, and I think that that's all we have. Yep. All right, well, let me know if you have any questions, and I'll see you in the starred problems video. Have a great day.